Welcome to the lecture number 39. So, we have been discussing about the spin stabilization of a satellite and that too in the presence of gravity gradient. So, we will continue with that. So, last time we have derived various relationship regarding the angles involved and the angular velocity involved. So, now we write the Euler's equation, dynamical equation here. So, I 1 times omega 1 minus I 2 minus I 3 times omega 2 omega 3, this equal to minus 3 omega 0 square times I 2 minus I 3 and then C 2 C 3. If we write it like this, we do not need to remember much. Okay. Any time you can reproduce this equation. So, these are the three Euler equations we have. We assume that I 2 equal to I 0 and I 1 equal to I 3. So, we are going to analyze the system under this condition. So, this is our assumption. For this case, the system becomes this system equation will this the whole dynamics it will get simplified. So, what we can observe that the second equation from this place, this is I 0 times omega 2 I 3 minus I 1. So, this part becomes 0 and on the right hand side also this part, this is dot, here dot is missing. So, I 0 times omega 2 dot minus omega 0 and this part is 0, this part will also become 0. So, this equal to 0 and this implies omega 2 dot this equal to 0 and omega 2 this is a constant. So, under this situation a constant angular velocity can be maintained along the two body axis. Rest we have to deal with the first and the second equation. So, the first equation we can write as omega 1 dot I 2 is I 0 minus I 3 is I divided by I, okay. And then omega 2 omega 3 this is equal to minus 3 omega 0 square and C 2 3 and C 3 3. So, we pick up C 2 3 from this place, C 2 3 is this quantity and C 3 3 is this quantity. So, we need to insert it there, theta 1 C theta 2 theta 1 C theta 2 plus theta 3 is theta 2, theta 3 is theta 2. And I 0 by I 0 minus I divided by I, this quantity we are going to define as I minus I 0 minus I divided by this I. This quantity will define as k. So, from this place this becomes k times omega 2 omega 3, and again omega 2 omega 3 also we need to insert here. So, omega 2 omega 3 we have already derived omega 1 omega 2 omega 3. So, this we have derived and we will have to pick up this. So, in the next step we will pick it up and put here in this place. So, minus 3 omega 0 square k times theta 1 c theta 2 plus theta 3 s theta 2. Inserting the value of omega 1 here. So, omega 1 is theta 1 dot plus omega s theta 3. So, omega 1 is theta 1 dot theta 1 times theta 1 dot plus omega s theta 3 omega s theta 3. So, omega 1 dot will become theta 1 double dot. This quantity is a constant, this is constant. So, this will not change. So, we get here omega s times theta 3 dot. So, dimensionally all the terms are same. So, omega 1 dot becomes theta 1 double dot plus omega s times theta 3 dot minus k, and omega 2 omega 3 we need to insert. So, omega 2 from this place will look back, omega 2 is omega s. Okay. So, omega 2 is omega s, and omega 3 we need to insert. So, this is your omega 1 term, and this side I will write here omega 3 term, so that we can use here. Omega 3 is theta 3 dot minus omega s theta 1. So, this is theta 3 dot minus omega s theta 1. Therefore, omega 3 dot it will become theta 3 double dot minus omega s side theta 1 dot. So, we need to insert that here. So, this is theta 3 dot minus omega s times theta 1. So, omega 2 and omega 3, this is omega 2 and this is omega 3. 3 omega 0 square k theta 1 c theta 2 plus theta 3 s theta 2. We can rearrange this term to write it like this theta 1 double dot. Here this we see that theta 3 dot is present here in this place and also here in this place. So, we can write this as 1 minus k omega s common to this. So, omega s times theta 3 dot and then plus k times omega s square theta 1, this equal to minus 3 omega 0 square k times theta 1 times c theta 2 plus theta 3 times s theta 2. And if we bring this term on the left hand side, so also we can what we can do that we can bring this whole term on the left hand side. So, we can put a plus sign here, on the right hand side we can put 0. So, this is our one equation we have got here. And we will name this as the equation number 4. Now, this is for theta for the first equation we have worked on. Now, we have to work with the third equation. Second equation we do not need to work, because already this has got simplified to this particular result. So, the third one I 3 omega 3 dot, similarly we can write omega 3 dot this equation we have brought it here on the left hand side and written like that. So, omega 1 omega 2, this becomes omega 3 dot, and here we will take the minus sign and I 0 write it like this. So, this will become k, and the same way here in this place we need to change. So, we will have a minus sign here 3 omega 0 square, and I 2 is I 0 minus I divided by I C 1 3 C 2 3, and this gets reduced to omega 3 dot. This part we have written as k. So, omega 1 omega 2 minus 3 omega 0 square, this is k, C 1 3 times C 2 3, this equal to 0. On the right hand side all these are 0. Now, insert the expression for theta 3 dot omega 3 dot. So, this is theta 3 dot minus omega s times theta 1 dot minus omega s times theta 1 dot, and then the rest of the terms we have to insert here. So, omega 1 is theta 1 dot plus omega s times theta 3, omega s plus theta 3, and omega 2 is omega s. So, we write it like this minus 3 omega 0 square k C 1 3. So, C 1 3 now we have C 1 3 is minus s theta 2. So, this is minus s theta 2, and C 2 3 again we have to pick up. So, C 2 3 is here theta 1 C theta 2 theta 1 C theta 2 plus theta 3 s theta 2 theta 3 s theta 2. So, this minus sign that will make it plus. So, I will remove this sign from here and I will put a plus sign here in this place, and this quantity will be equal to 0. So, this can be broken up and it can be rewritten like. Now, here we see that this term and this term both are present here in this place. So, this is 1 plus k times omega s times theta 1 dot, and then minus k times omega s square theta 3 plus 3 omega 0 square k this equal to 0. Here we need to put a plus sign while we are working with this I 1 minus I 2. So, what I have done that this part I forgot to change the sign here. This I 2 we are writing on this side I 1 and divided by I 3. So, this will come with a minus sign. So, this minus then get plus, the minus sign of this and minus sign this, that makes it plus. So, we will have a plus sign here, and therefore, we need to put a minus sign here in this place. So, this becomes a plus. So, if we take a minus sign out of this, so this is 1 minus k omega s times theta 1 dot, and then this particular term omega s square, here this is omega 0, this part is omega 0, which is the orbital angular velocity. So, this is our another equation that we have got theta 3 double dot 1 minus k omega s times theta 1 dot, and then okay. So, one more sign change here, we need to have a plus, because this we have made it plus. So, here also there will be a plus sign. So, this is the plus sign here. So, this is okay, k omega s square theta 3, and then 3, the other one it is already the plus. So, this is okay. Now, these equations we will number. So, this is the fourth equation, this I will write as this is the equation number 5. Now, these two equations, though looking simple, but the problem is that here in this place and also here in this place, this particular term, this one, these are function of sine and cosine, means these are the periodic terms. So, this term, this is a periodic term, and we need to simplify this equation, so that we are able to work with this. Without that, proceeding with this equation, it will be tough. Okay. So, in both these places, because of this particular the coefficient which is appearing, which is periodic term, we get in trouble. So, to get out of the trouble, we need to assume something, and assuming means we need to do some transformation here. Okay. With appropriate transformation, we will be able to put the equation 4 and 5 in a proper format, and thereby we will be able to work with them. So, for let us assume that alpha 1 equal to whatever the coefficient is appearing here, theta 1 times c theta 2 plus theta 3 times s theta 2. So, this is our equation number 6, and similarly alpha 2 we assume as minus theta 1 times s theta 2 plus theta 3 times c theta 2. And very soon it will be clear that indeed this helps. Okay. Okay. Now, once we have assumed this, so we can solve it in terms of theta 1 and theta 3. So, from here our objective first is to get theta 1 and theta 3. So, once we get this theta 1 and theta 3, so we will in terms of alpha 1 and alpha 2, so we will insert in this equation and in the previous equation here in this place. Okay. And by inserting, we will be able to simplify these equations quite a bit. So, multiply equation 6 s theta 2 and equation 7 by c theta 2 and add. So, if we do that, so we have alpha 1 c theta 2, alpha 1 times this we have to multiply by s theta 2 and plus the other one alpha 2 times c theta 2. So, this will be equal to alpha 1 value we have to insert here in this place, this alpha 1 what we have assumed. Okay. So, alpha 1 is theta 1 c theta 2. So, this is theta 1 c theta 2 plus theta 3 s theta 2 multiplied by s theta 2 and plus this alpha 2. So, alpha 2 is minus. So, here this particular part is changed, minus theta 1 times s theta 2 and plus theta 3, this remains same and s becomes c theta 2 and this multiplied by c theta 2. So, we can check here that this quantity is s theta 2 c theta 2 plus theta 3 s theta 2 square, and from this place we get as theta 1 s theta 2 times c theta 2 and plus theta 3 times c theta 2 square. here we have this term is plus, because here this is plus. So, this is plus. Now, we can see that theta 1, this particular term and this term, they cancel each other. So, these two terms they cancel each other, and therefore, this is theta 3 times s theta 2 square plus c theta 2 square. So, this is theta 3. So, theta 3 we have got in terms of alpha 1 s theta 2 plus alpha 2 c theta 2. This is we have written here alpha 2. I will change it to the notation alpha 3. I will change it to notation alpha 3. So, this is alpha 2, here we will write in terms of alpha 3. Okay. So, theta 3 is, and reason behind this is simple, because we have already observed that your omega 2, this turns out to be a constant. Okay. Going back here, in this place, this term is a constant. So, this does not change. So, we will directly associate the angle theta 2 with alpha 2. Okay. So, alpha 2 will reserve for that, and alpha 3 we will keep for this is the rolling motion, this is associated with the rolling motion, and this is associated with the yawing motion. This is associated with rolling, and therefore, it is appropriate to keep the terms alpha 1, alpha 3 here in this place. Okay. So, in the same way, if we multiply 6 by c theta 2 and 7 by s theta 2 with minus sign, minus s theta 2, and add. So, 6 and 7, these two equations, we are multiplying it by c theta 2 and the other by minus s theta 2 and add. So, in that case, this will be alpha 1 times c theta 2 minus alpha 3 times s theta 2. This will be equal to, now alpha 1 we have to pick up. So, alpha 1 already it is available here in this place. So, we insert that theta 1 c theta 2 plus theta 3 times c theta 2, okay, and minus alpha 3 is this term. So, minus theta 1 s theta 2 plus theta 3 c theta 2 and multiplied by s theta 2. The expanding this yields c theta 2 square plus theta 3 s theta 2 c theta 2 minus that gets plus. So, this is theta 1 times s theta 2 square, and here plus minus this gets with a minus sign, theta 3 s theta 2 times c theta 2. So, this term and this term they drop out, leaving us with these two terms. So, these two terms added together, we do not have a space here, we will go on the next page. So, we have here theta 1 square c theta square, theta 1 times c theta square, theta 1 times s theta square. So, that makes it theta 1. Okay. So, theta 1 times s theta square s theta, this is c theta 2. Okay. Theta 1 times is theta 2 square plus c theta 2 square, and on the right hand side, then thereafter we can pick up this term and write here alpha 1 c theta 2 minus alpha 3 s theta 2. So, the theta term 1 becomes alpha 1 c theta 2 minus alpha 3 s theta 2. So, finally, we conclude all the results here. So, theta 3 what we have got here in this place, this is alpha 1 s theta 2, alpha 1 s theta 2 minus this is plus alpha 3 c theta 2 plus alpha 3 c theta 2, and till now we have used the notation till 7. So, this will write as equation number 8 and this as the equation number 9. Now, from here onwards this derivation is very stretching, okay, but it is a good to have a practice of this, so that you understand the whole process how the things are working. Now, thereafter we need to get alpha 1 theta 1 dot and theta 3 dot, theta 1 double dot and theta 3 double dot, and these terms then need to be inserted into the expression we have got here in equation 5 and equation 4. Okay. So, find these terms and insert in equations 4 and 5. And we have to do it patiently, because it is a quite time taking work. Okay, so, theta 1 is alpha 1 c theta 2 and alpha 3 s theta 2, alpha 1 s theta 2 and alpha 3 c theta. Now, let us rewrite this, so that we do not have to carry this tag 2. Okay. So, we will write this as theta 1 equal to alpha 1 c theta minus alpha 3 s theta and theta 3 this equal to alpha 1 s theta plus alpha 3 c theta. So, we are dropping, we have this I will write as 9, this is 10 and this is equation number 11. We have dropped the suffix 2 for convenience. Okay. Thereafter, we can take derivative of this. So, if we take derivative of this, so theta 1 dot then will be alpha 1 dot times c theta and minus alpha 3 dot times s theta, and the other term then we have to differentiate, alpha 1 times c theta will be then s theta times theta dot, and minus sign will appear here in this place. Okay. And there is a minus sign already with this. So, this is alpha 3 s theta will become c theta times theta dot. So, remember that the theta 1, theta 2 these angles and theta 3 they are being measured with respect to the orbital axis system. So, therefore, appropriately we have to put here theta dot, and in the beginning itself we were discussing about this. So, your theta dot quantity we have to write here. So, theta dot will be omega s plus omega 0. Why? Because your this is the satellite and inside going this is your 2 axis, downward your 1 axis and this is 1 and this is the 3 axis. Okay. So, rotation the omega s we have shown it like this. Okay. And theta dot is the rotation with respect to the theta dot, here this is the rotation with respect to the orbital axis. Okay. So, we will write it on the next page. So, we will have omega s, this is the absolute angular velocity, this will be equal to omega orbital angular velocity, and with respect to this then you have omega r. This is the relative angular velocity which is with respect to the orbital axis system, and omega s and omega 0, omega s and omega 0. So, your because the velocity of the satellite is along this direction. So, omega 0 is along this direction. Okay. So, omega 0 is here, while your omega s it is going here in this direction. So, we can see that they are opposite to each other, okay. And therefore, while we write here, so we convert it in the same frame. So, it becomes omega 0 with minus sign. So, this goes along the, if we put a minus sign here, so that becomes along the 2 direction, okay, and plus omega r. So, omega r is nothing but your theta dot, okay, if we are looking only for the pitching one. So, theta dot is with respect to the orbital frame. So, theta dot along the 2 direction, it is a theta dot. So, now the theta dot we have and omega 0 we have chosen along this direction. This is the omega 0 direction and omega s is along this direction. And we are measuring with this frame is, the orbital frame is rotating this way, and with respect to this we are measuring theta dot. So, obviously, it will add this, and also theta dot, if we write here. So, you can see that theta dot it will be equal to omega s plus omega 0. Because you are measuring theta dot with respect to the orbital axis. Okay. So, something is rotating like this, and then you are measuring with respect to that. Okay. So, if we have inertial frame, so with respect to the inertial frame only we have omega s, okay. And but now we are measuring with a frame which is rotating here in this direction. Okay. So, if this is rotating here in this direction, so obviously you can see that omega s plus theta dot it will add, and this will show omega s plus omega 0, this will add up, and this will show you what is the rotation rate with respect to this axis. So, this becomes your theta dot. So, this is exactly what has been written, you can check it yourself. Okay. These are the things we have discussed a lot right in the beginning, and it is a pretty time taking these issues. Explaining here, especially through this computer. In the classroom, it is very easy to discuss all these things, but on the computer it becomes little difficult, because it takes a lot of time. Okay. So, what we have got here, this theta dot equal to omega s plus omega 0. Now, this is the theta dot term which is appearing here in this place. So, we can write here theta 1 dot this equal to alpha 1 dot c theta minus alpha 3 dot s theta, and here this minus sign is there. So, minus sign we can take it outside, alpha 1 s theta plus alpha 3 c theta times theta dot. Okay. alpha 3 dot s theta minus alpha 1 s theta plus alpha 3 c theta, and theta dot is on this side whatever the value we have. So, we need to put it here, this is theta dot. Okay, so the same term, okay, this is not required here. Okay, in the same way, once we have got this theta dot term, okay. Now, theta 1 dot we have got here. Similarly, theta 1 double dot we can compute. So, theta 1 double dot theta 1 dot. So, this will be equal to d by dt, and theta 1 dot we have to pick up from the previous page. So, that becomes this quantity again we have to pick up and write here. So, directly we are differentiating the first term. So, we remove this part here. And then the other part, this particular part we have to take the derivative, and also c theta and s theta they need to be differentiated. So, theta dot we can write this as omega r, this quantity we can write as omega r. So, that we may be comfortable with writing. So, we are picking up this term alpha 1 and s theta differentiated, we are taking up this term. Okay. So, alpha 1 times s theta differentiated, that becomes c theta. So, alpha 1 times c theta, and theta dot will appear. So, theta dot will take it outside, okay. And this term alpha 3 c theta. So, that becomes alpha 3 times going back here, we have first differentiated alpha 1 dot term. So, this term is okay. The other term we are differentiating first this part s theta and c theta. There is no problem, you can differentiate in any order and write it. So, alpha 3 c theta. So, that becomes alpha 3 s theta times theta dot, and already this theta dot was present. So, that becomes theta dot square. Okay. Then the corresponding term for this we have to take care of alpha dot, and c theta is there. So, this becomes minus s theta, okay. And then minus alpha 3 dot, this be differentiated, that becomes c theta times theta dot. Okay. Similarly, here in this place, this is with minus sign here. So, this is minus alpha 1 dot times s theta, and then alpha 3 times alpha 3 dot times c theta plus alpha 3 dot times c theta times theta dot. So, these are the terms we have got here. Okay. And if we replace this theta dot by omega r, so it will be like we do not have to carry this square and the other terms. It becomes little easy to work with. So, theta 1 double dot, this will be alpha 1 double dot c theta minus alpha 3 double dot s theta. You can see this term alpha 1 dot is here, and alpha 1 dot alpha 3 dot is here. So, here this minus minus it can be taken outside. So, this becomes minus this term and this term together, this becomes 2 times alpha 1 dot s theta plus alpha 3 dot c theta times theta dot, and then this term, this particular term we have to consider here. So, this is alpha 1 c theta minus alpha 3 s theta times theta dot square. Okay, so, instead of writing it like this, we write here as alpha 1 double dot c theta minus alpha 3 double dot s theta minus 2 alpha 3 dot c theta times omega r minus alpha 1 c theta minus alpha 3 s theta times omega r square. So, till now we have got here all these things. So, this will number as theta 1 dot, this we number as 10, no 10, 11 already it is there. So, this we number as 12, and this equation we number as equation number 13. Okay, so, the same way theta 3 dot can be computed, and once we have done this, then we can progress further by inserting all these terms in the equation that we are writing here, this equation and this equation. So, we can insert here those terms in these equations, and we will get the result. So, we stop here this lecture. We will continue in the next lecture. Thank you very much.